In my presentation, I forgot to mention that to operate our satellites and ground station, we established a remote sensing operator on the premises of Russian space system JSC. So I'd like to bring up on stage Mr. Alexey Peshkun, deputy head of department of that operation. He will tell you how they do data processing of Kanopus-V images for mapping and other applications. The operator is located at Otradnoye. We're going to establish a JSC, joint stock company, with a distributed network, headquarters at Otradnoye and 2 branches in Vanino and Kalyazino. In Kalyazino we will put down a backup storage facility. DigitalGlobe told us interesting facts. I guess we will buy some trucks too to carry around our data, make it data on the move. So we will follow in your footsteps in that regard. We'll follow your suit. Thank you, distinguished colleagues. I represent the operator of the remote sensing data. My presentation comes last in this session, so I will try to cast an operator's look at what the previous speakers told you, and I'll share with you a small processing example, a case study. So the operator, we as the operator on a par with other operators, collect requests from users. We schedule and plan imaging assignment. We catalog and archive data, and we release products. There is an information center attached to the operator that promotes the international vector. This is dedicated to large disasters. Plus, we provide Roscosmos with various analytical materials. Besides, Russian Space Systems JSC designs ground stations, data storage stations, designs equipment that is established, mounted on a resource. So it was designed on the premises of Russian Space Systems. A few words about coverage of Russian Federation with information, because it is the Russian orbital constellation that should serve the needs of socio-economic development of the country. So we can see how data build up over years from resource P and information from Kanopus-V. We've seen this slide before several times. This is ground infrastructure for Roscosmos and Roshydromet. These ground stations provide daily more than 120 daily sessions of information reception, and there is a turnover of 3 terabyte within the system. We can see data supplied to customers between 2010 and 2016. As you can see, the constellation gradually builds up. needs are increasing based on 2016 results. We have additional 36 new customers, various municipalities. So the number of tasks we're doing is also increasing. So as I proceed to photogrammetric dimension, I'd like to say that the operator is engaged in the implementation of the Digital Earth program mentioned yesterday and today. Of course, this program relies on images from space primarily. The quality of data will affect the end product. It will affect processing quality. So I'd like to tell you about geometric properties of images from Kanopus-V. Many of you know that there is very specific imaging equipment used by Kanopus-V, and the level of processing that any consumer can use for further processing is first level. These are micro images. Per one strip, there is a lot of micro images. Previously, customers only had access to level 1 that could be used for further photogrammetric processing. Since recently, a new product has been developed that's 2A level. Now it comes with RPC coefficients, and consumers can use enlarged sections of the strip, meaning they don't have to process thousands and thousands of micro images. They can do with enlarged fragments. So how good are these images geometrically? So in order to verify, we decided to run a photogrammetric check and to see how one stereo pair is doing from two overlapping routes. So these are two overlapping routes from Kanopus-V per area of interest with convergence angle of 26 degrees. The control and check data was 25 centimeter ortho photo plans and a digital terrain model generated by LiDAR with 5 meter spacing. These are how these strips are positioned. It's Spain. This is control and check data. Fragment, orthophoto plan, and a DTM. This is a panchromatic original image, and we lighted micro images, which, if processed by customers, will have to be processed as an autonomous strip. That increases the the amount of time you need for processing, as opposed to enlarging them. This is how we split the route into two parts. We use the underlying surface as a reference, so each route was split into two parts. The first fragment falls onto a flat land, the other falls on the mountains. So these are two overlapping routes. This is how they superimpose over the underlying surface. This is the accuracy of stitching. The RMS, the greatest one, is registered for the second strip. It was a half pixel error. This is location of stereo pairs and GCPs, data derived from orthophoto plans, and altitudes were derived from DTM, generated by laser scanning. Here you can see accuracy estimation of block adjustment. As you can see, the RMS error in the position is 1.4 meters. The maximum is 1.9, which is less than 1 pixel. And in terms of height, the RMS in height is equivalent of 1 pixel. There's a checkpoints accuracy verification. In the position it's about 1 pixel, slightly less than 2 pixel. And the maximum error in height is around 2 pixels. My tables don't have this, but the RMS error on tie points is about 2 pixels, and the maximum error is 2 pixels. We don't think it's a bad result. Later, we generated a DTM using photomod in an automatic mode with no human interference. If any gross errors were made, we didn't correct them. There were some mistakes though. Now we can see that one dot is an outlier. We excluded it, scratched it. After elimination, the digital terrain model generated based on GCS and checkpoints. The RMS was 2.7 and max around 5. So that's 2 pixels max. I think this deviation is quite okay. We made another comparison. We built a difference model of DTM generated stereoscopically from Kanopus and a DTM based on aerial laser scanning. So we can see deviations of DTM generated stereoscopically from the reference one. As we can see, 7.5% of points have deviation up to half meter. If we take an error up to 1 pixel, 38% of nodal points fall in that range. And up to 3 pixel error, 76% of points fall in that range. So we can see larger deviations marked in purple. They happen to be in the mountains, on the hills. With manual intervention, I think the result can be much improved. So this 2A level product with RCA coefficients that now come as a standard can be used for photogrammetric processing to create various geoinformation products. And they will be of good quality with good geometric parameters and properties. My presentation is over. Thank you. If you have any questions, I'll be happy to answer. I would like to ask a question. A couple, actually. Firstly, you said as the operator, you process data, right? What kind of software do you use for thematic processing of data? Photomod is included in your is it included in your processes, or is it your own decision? Photomod software is used for photogrammetric processing. In other words, to create ortho photo plans, seamless coverages, and creating DTMs, 3D models, on a pilot basis. And as for thematic processing, which we're beginning to explore heavily, we're going to use software from CIT company, that's Image Video Center. I hope that after lunch we will have more presentations uncovering capabilities of other companies, not just Photomod. I basically have the same question. A previous speaker said that we have 10 testing grounds, some methodology, but you say that you are an operator, and again you did some pilot over Barcelona using your own methodology. Maybe you should revise your policy on that. And since you are the closest, I gotta ask you, when Roskartografia, my agency, would get 100% end-to-end coverage of Russia? Thank you for your question. For the first part, I'd like to observe that we don't have high accuracy DTMs for our testing grounds. And for Spain, there were open source high accuracy DTMs. We had a What do you mean? How come we don't have high accuracy reliefs? Can't we use resource P to acquire data to generate good DTM? Alexander Georgievich, can we do it? I guess it has to do with the quality of relief. Space laser scanning will not do a proper job. In Spain it's 30 centimeter. Okay, I'll have to deal with it. I'm gonna put it under my control. Thank you. There was a second question, a sub-question. About end-to-end coverage. We have the coverage by Kanopus and resource P for mapping purposes. Roscosmos since 2014 has been doing end-to-end coverage of Russia using all satellites at our disposal. In 2015 we did full coverage. I'm not talking about clouds now. So each year Canopus covers the whole of the country. Today resource P, we have a slide on cloud cover. So with 10% cloud cover, which is one of your caveat, so by resource P 80% of the country is covered. Considering 20% cloud cover, 95%, 30% cloud cover, 100% coverage. Our colleagues tried to impress us with petabytes, but we use prontobytes. Prontobytes is way ahead. So what we're doing is stitching all this data and storing it in the cloud, so that the customers, including Cartographia, could see any point of the Earth and any point on the planet. And one more question about deviation from nadir. You said 95%, 30% cloud cover, 100%, but nadir deviation should be 15%, right? Could you say that again? Deviation of nadir on images. Okay, let me put it this way. We're looking at 15%, 15-degree deviation, but some customers, like emergency ministries, forestry ministry, they need fast data about forests ablaze, floods. So for them, we image data even with 45%, 45-degree.
But it's not enough. About 90% of our images had a deviation no more than 15 degrees. Secondly, we work upon the request from Rosregister. Whatever request we receive in 2017 or late 2016, we do work on. So this request has been completed by 78% upon the conditions we have put into this request: 10%, 10-degree angle and the cloudiness and everything. Okay, question for Alexey. I think you exaggerate the capacities, or rather the needs, of laser scanning for building orthophotos of 2-meter pixel size with 2-meter resolution. Because for that it would be sufficient if we speak about Russian testing grounds and the existing landscape. It would also be good to build the dense model using Photomod or Photogrammetric, other Photogrammetric products. Here I would partially agree with you, but still I compared it to some kind of reference, and the more precise the reference, the more correct would be such a comparison. And then again, this landscape is an open source material. It's open. I used whatever was more convenient for me. I didn't have to recreate it again. I also had data. I had the acquisition for this area. That's why I did that area like this. Okay, thank you, Alexey. Dear colleagues, are there any other questions for the operator? No questions. To conclude this panel, I would like to thank all the speakers of the pre-lunch session. It gives me pleasure that despite the sea and good weather outside, the number of participants of our section has grown. At least isn't less than the first day. And credit here goes to the organizers of this conference, our colleagues from Israel. It proves that it is of interest to everyone. I would also like to ask everyone here, because here we have people who are specializing in Earth remote sensing. Now we're working on the legislative regulation and of commercial appeal of Russian space data. On behalf of Roscosmos, we submitted almost to all organizations and companies, including commercial companies, for their proposal on what needs to be done now. Like, we have lifted all the restrictions. Nothing prevents disseminating it. Maybe the data quality is not okay. Maybe we need to undertake some organizational measures. Maybe we need to legislatively regulate it. Because we haven't received any proposals from anyone, although we submitted a questionnaire about a month ago. 6 distributors decided on the sale of Russian data. I still don't understand something. What's happening in our country? Maybe it's just because we give it for free to all the federal agencies and state authorities and nobody else needs this data. Then I don't understand. or are we just impotent here, meaning that we cannot establish our own marketing policy? So based on the results of this conference, so there will be a resolution, could we put down submission of proposals to the lawmakers also onto the resolution of the government number 370, the only one which permits commercialization of the Earth remote sensing data. And second thing I forgot to tell you, I will repeat myself, now we are producing a law on the Earth remote sensing data. Maybe we'll prescribe it there. The draft law has already been endorsed by all, including under the interdepartmental group, and the terms of reference have been issued. And I'm sure that by November it will be submitted to the government of Russia, and we'll start working on the text of the bill itself. So please, colleagues, don't be shy, submit your proposals, and maybe some foreign experience of our foreign colleagues might be valuable for us. People from DigitalGlobe, our Israeli colleagues, you're welcome to submit your proposals. I would disagree with your comment. I will remind those colleagues who maybe don't remember the resolution of government number 370 as of 6th of June 2005 was issued because of the launch of the first civilian satellite resource decay. Then we had some restrictions on the dissemination of data of the resolution better than 2 meters, and indeed there were this 3 restriction threshold there. That's why the authorized organizations you had to get approval from the Ministry of Defense. So all of these restrictions have been lifted. Now the resolution of government put in force the provision on how to plan space acquisitions from the satellites with the resolution better than 2 meters. Number one, it's not obsolete, it's still there. All these provisions are like the law. They prescribe how to organize space acquisition for the needs of state organizations, first of all. We have instruction from the government to make sure that we disseminate or apply this government decision on all satellites of the whole constellation, like be it environmental or hydromet resources, then remove the word less than 2 meter resolution from the permit, and then prepare a proposal and maybe include it into the resolution of this conference, so that we will have a proposal on how to commercialize these things. We need to do something. Nobody can tell for sure what needs to be done. Over the past 6 or even 8 months, we worked with distributors. We provided all the data imaginable, and I don't understand. If we need to change the licensing agreement or sub-licensing agreement, we're prepared to do that. But I don't understand why. That is why now we're going to make a decision to make sure that any customer interested in this remote sensing data could become a distributor. This decision hasn't been made yet, but it will be reported to the government. At least I personally will support it, because I don't understand why those 6 distributors that we have cannot manage it. That's what I call it, to sell and disseminate this data commercially. That's why, Viktor Viktorovich, if you have any concrete proposals, come forward with them. But we need to distinguish between target use of high resolution satellites is one thing, but hydrometeorological satellites you don't need to plan or turn around, just like Meteor, just like Electro. That's why there is no need for that. And the only thing we can do, we might have a separate resolution of the government on meteorological satellites, I don't know, but otherwise we see no need to do anything else, because they're not obsolete. And after the issuance of the law on remote sensing data, perhaps, not even perhaps, but I'm sure that will introduce relevant changes in all other laws and bylaws, and at the same time we have plans to issue a provision on commercial use of remote sensing data. Remember when United States launched Landsat system. Thank you, colleagues. If there are any other questions, I can take them for Roscosmos or its operator, we can answer them. Thank you, colleagues. Then at 1 p.m. we have lunch. At 2 p.m. we regroup once again. So stay frosty and bring your friends.